In this video, you will see how the sun is no ordinary star, how it carries the greatest potential for disaster in human history, and how massive solar flares, which are sure to occur one day, could bring the modern world to its knees. We explain step by step, from the perspective of science, the internal structure of the sun, its magnetic cycles, how explosions occur, and how they can affect our planet. If you are ready, let's delve into the depths of cosmic truth together. The sun that rises in the sky every morning is much more than a source of light that gives life to humanity. It's a giant nuclear reactor that has been operating continuously for 4.6 billion years. It's truly incredible, isn't it? In the core of this giant star, whose diameter is 109 times that of the Earth and whose mass is 330,000 times that of the Earth, 600 million tons of hydrogen are converted into helium every second, releasing energy equivalent to the simultaneous explosion of millions of nuclear bombs. This energy passes through the radiation zone inside the sun before reaching the surface, where it is then carried by giant convection currents and eventually radiates from the surface into space. However, contrary to popular belief, the surface is not solid. It is an ocean of plasma that boils, rotates, rises, and sinks. This plasma mass rotates in approximately 25 days at the equator and 35 days at the poles. So different parts of the sun rotate at different speeds, and this stretches the magnetic field lines like a giant bent rubber band. As the voltage increases, the magnetic field lines become entangled, compressed, and eventually experience a sudden disconnection called magnetic reconnection. This moment of rupture is the beginning of the biggest explosions on the sun. The sunspots we observe on the surface are traces of this magnetic irregularity. The more spots there are in an area, the more energy is accumulated. The sun has an 11-year magnetic cycle, and as the maximum period approaches, the spots increase, the explosions become more frequent, and the sun becomes more aggressive. The power of explosions is measured by X-ray classification. Classes A, B, C, M, and X. Class X explosions are the most powerful, with each level of X carrying much more energy than the previous one. Values like X10 and X20 are the most dangerous explosions. The Carrington explosion, one of the largest events in history, is considered to be between X45 and X60 according to current measurements. In fact, solar flares aren't just one type. Some are solar flares that occur within seconds and reach Earth in just 8 minutes. These carry X-rays and ultraviolet radiation. They can instantly disrupt radio communications. More dangerous are CMEs, because they contain a mass of actual plasma dense enough to shake the Earth's magnetic field. There are also incredibly fast particle streams called solar energetic particles. These are particularly deadly for astronauts and satellites. Combined, these events could literally bombard our planet. It is enough to look at history to understand how real this possibility is. In the year 1859, an astronomer named Richard Carrington observed an unusual flare on the sun through his telescope. Nothing was happening on Earth at that moment, but just 17 hours later, humanity was faced with the largest geomagnetic storm in history. Telegraph lines caught fire, operators were electrocuted, and from Europe to America, the northern lights filled the skies like a blood-red curtain. At that time, there were no electrical grids, no computers, In other words, the greatest chance was that this disaster occurred in an era when humanity was not yet dependent on technology. If an event of the same magnitude were to occur today, its consequences would not be limited to a few telegraph wires. The Great New York Railroad Storm of 1921 disrupted train signals and disrupted communications. In 1989, a moderate solar storm in Quebec left 6 million people without power for hours after a single transformer was damaged. And it wasn't even a big deal. We see that while humanity remains fragile, even in its smaller incarnations, a Carrington-scale explosion is enough to bring the modern world to its knees. It's terrifying to even contemplate. A giant plasma cloud erupting from the sun hits Earth directly.
The first signal comes 8 minutes after the explosion.
These X-rays and radiation disrupt high-frequency radio communications, with some aircraft experiencing momentary disconnections. But this is just the beginning. The real danger is the coronal mass ejection that will arrive hours later. The Earth's magnetic field is like an invisible shield. When this shield encounters the charged particle coming from the sun, it compresses, bends, and breaks in some places, just like a giant balloon. These fractures cause electric currents to flow towards the surface. Transmission lines hundreds of kilometers long inadvertently turn into giant antennas. The current is loaded into the transformers. The transformers overheat, and some begin to physically melt. If this process cannot be controlled, a chain reaction of power outages across continents could occur. When one country loses electricity, the load on neighboring countries increases, which strains their transformers. It is possible that within a few hours, large parts of Europe, America, or Asia could be plunged into darkness. When the power goes out, the internet backbone can't function, servers shut down, financial systems come to a halt, and GPS signals either disappear completely or drift off by several meters. Satellites may be thrown off their orbits by the effects of a magnetic storm. Some may even descend and begin to fall uncontrollably due to increased friction in the atmosphere. The upper layers of the atmosphere heat up, expand, and increase the frictional resistance of the satellites. This process affects not only satellite navigation, but also weather, military communications, the global internet, and countless other modern technologies. At the same time, the northern lights, which we call aurora, can descend to the equator. Even in cities like Istanbul, Rome, Cairo, or Mexico, the sky can be covered in a curtain of pink, red, and green. This magnificent image is actually a sign of the blow that the Earth received. The worst-case scenario plays out in science's darkest but most realistic simulations. Imagine a situation where a massive explosion hits the Earth directly, and the global electrical infrastructure could collapse within hours. Within a few days, the consequences could include a complete loss of internet connections, the banking system coming to a halt, planes flying in manual mode, hospitals running on life support devices with only generators, and the global supply chain coming to a halt. Dark cities, malfunctioning devices, a world without communication, an environment where all of humanity's modern dependencies suddenly disappear. Scientists call this the prolonged darkness, because replacing transformers can take months, or even years in some cases. Of course, humanity is aware of this possibility. NASA, ESA, and many other space agencies use sophisticated telescopes and probes to monitor such hazards. Missions such as SOHO, SDO, and Parker Solar Probe keep the sun under constant observation. When a possible CME is detected, a warning can be made 15 to 60 hours before it hits Earth. Some countries have begun developing systems to isolate critical infrastructure in this situation, but much of the world remains vulnerable. Most giant transformers, in particular, are not resistant to such a magnetic storm, and replacing them is no easy task. The production of a transformer can sometimes take over a year. Internet cables, satellites, and energy systems were not designed with solar storms in mind. And most importantly, most societies cannot even imagine the consequences of such a disaster. All this information tells us this: a major solar flare is not just a question of will it happen. It is an event that will definitely happen one day. The only unknown is when this will happen. Maybe in the next 10 years. Maybe in 100. But it remains a reality that future generations will undoubtedly face. In conclusion, the sun, besides being the star that gives life to humanity, is potentially the greatest weakness of modern civilization. One day, an invisible storm coming from the sun may suddenly silence the world. We may wake up to a world without electricity, internet, or communication. But at the same time, humanity has an extraordinary ability to adapt and rebuild. The most important question to ask is this: How prepared are we for a cosmic storm with today's technology and today's preparedness? Don't forget to like the video and subscribe to the channel for more science, space, and mystery content. See you in the next video!